We're asked to find the Thevenin equivalent circuit looking into terminal A and B. This is our terminal A and B. This is for the impedance, that's we're going to find the Thevenin equivalent for our circuit. Then we also need to find the current Ifs in the primary side. So this current, and that is to the left hand side. And we're also given this V of G right here. Now what we're going to do is use Kirchhoff's voltage law. So we know that there is some current flowing through this part of our circuit, and it is going this way, we can say. And this will be our I1, this is current 1. And we know that there's a second current flowing through this part of the circuit that's different from our I1 because they're not connected, they're just connected through mutual inductance. So we are going to have the current flow through the same way, like this. And this is our I2. Now we're going to solve for this using Kirchhoff's voltage law. Kirchhoff's voltage law, for the first one, we have this Vs right here. And this Vs, the voltage drop is from the positive to the negative, so it's going in the opposite direction of our I1. Since it's going in the opposite direction, it's going to be a negative, so we're going to have a negative V of S. And then we're going to have a plus. We're going to look at our I1, and then we're going to have all of the impedances on this side with our I1. So we're going to have I1, and then in parentheses, we will have the 8 plus J8. So the impedance times the current. That's how you get voltage. And then after this, we are going to have a plus, and then we are going to have our I2. Now our I2 is splitting this way. So that means our I2 is basically going across this right here. What that means is that we are going to have a plus, like we said right here. We are then going to have our I2, and this is being multiplied by the J5. And this will all be equal to 0. Now we're going to look at the second part right here, and we are going to find the voltage for it. We're going to use the same formula. So we don't have any voltage in here, so we are not going to have like some V of S. But what we are going to have is our I2, and then inside of our I2, we are going to add all of the impedances together. So we're adding all of these together. If we add, we have this 12 ohm resistor, and then the rest are in J. So they're imaginary numbers, they're either inductors or capacitors. So we're going to add all these together, and this is going to give us a plus J times 12. And then we are going to have this I1 that we know is coming over this way. And so since we have this I1 going across this, we are going to have plus I1, and this is being multiplied by the J5, and this is all equal to 0. Now we want to solve for our I2, that way we can plug it back in here and then solve for our I1, because we are given our V of S. Our V of S is right here, this 15 with an angle of 0 degrees, and we're going to plug that in a second. Before the second one, we're going to solve for, again, our I2. So if we were to do this, we're going to say that our I2 is equal to, we are going to subtract a I1 J5 from both sides, so we're going to have a negative I1 J5, and this will be divided by the 12 ohm resistor plus the J times 12. Now we can plug this into a calculator to solve for the imaginary number. And if we plug this into a calculator, our I is representing our J here. We are going to get this as our answer. Negative 5 over 24 minus I, which again is J, times 5 divided by 24. And 5 divided by 24 is 0.208. So when we write this, we're going to have the I2 is equal to I1 minus the 0.208. We're then going to have a minus J times 0.208. And this is our I2. We found it. We can plug it back into this part right here. And so that's what we're going to do. We're going to come down here and start writing this. We can add Vs to both sides, that way we'll get it on one side and it won't be negative anymore. And if we do this, we're going to get that our V of S is 15 angle 0 degrees, and this is equal to the I1, and then we're going to have 8 plus J8, and then we also have the I1 because we're plugging this I2 into here. So we're basically going to have this times this. So we are going to have an I1 on the outside. We are going to have a parenthesis. Now a J5 times a negative 0.208 is equivalent to negative J 1.04. Now if we take this J5 and multiply it by this negative J 0.208, the J's are going to become a negative 1, so we basically have a negative times a negative 1. This is going to give us a positive, and then we're going to have a 1.04, and so this is going to be our answer. What we're going to do is add our I1 values together. We can factor out the I1, and then we're going to divide both sides by what we've added together. And if we do that, we are going to get that we have a 15 with a 0 degrees angle, and this is over 9.04 with an imaginary number of plus j times approximately, we'll say 7. And this is equal to our I1. Now we can't divide or multiply, for that matter, two different things. This is in polar form, this is in rectangular form. So if we're dividing, the simplest way to do this is to convert this down here into polar form. To convert to polar form, we're going to have that our Vmax, or in this case, it'll be our Imax, is equal to the square root of our real number squared plus the imaginary number squared. And then we're going to have that our angle is equal to tangent negative 1, and then we're going to have the imaginary number over our real number. So that is how you would go about doing that. If we divide this out, we are going to get that our I1 is equal to the 15 with 0 degrees. And then on the bottom, we are going to have 11.4 with an angle of approximately 38 degrees. So when we divide this, we are going to divide the numbers and subtract the denominator angle from the numerator angle. And then we're going to get that our I1 is equal to approximately 1.3 with an angle of negative 37 degrees. Now, our I1, we're trying to solve for our IS, at least for the second part. We're trying to find the current I of S. And if we look in the diagram up here, we can see that the I of S is really our I1. Our I of S is going to be going in this way. Some of it's going this way, but it's going to be going just like this. So we're going to use them interchangeably, and we can write that our I1 is equal to our I of S. However, this is not the answer. Our question is asking for it in rectangular form. So we need to convert from polar form to rectangular form. And to do this, we are just going to use the number, and then we're going to have a parenthesis, cosine of our angle plus j times sine of our angle. And this is going to give us 1.04 with an imaginary number of minus j 0.8. So if we reveal this, we are going to see that the answer is approximately these values. One thing to note though, we got lucky here, but when we convert from rectangular form to polar form like this, you need to check the angle, because this could be off by 180 degrees. To check the angle, you just graph this out real quick. You look at the imaginary number, that's on the y-axis, it's positive, so it's going to be up here. We look at this number, the real number, and it's positive, so it's going to be on this side of the x-axis. So that means our angle has to be somewhere in this quadrant. So we have 38 degrees, meaning it is in the first quadrant. However, if it was in this quadrant, all we would need to do is add 180 to get to that quadrant. So that is how you check the angle. Now we need to solve for ZT of H. ZT of H is really just impedance. So you can think of ZT of H as kind of like resistance in a way. Basically, it is the Ohm's law kind of, where we have the voltage over our current. That gives us resistance or impedance. So the voltage for our case is going to be the V of S. So this is equal to a 15 with an angle of 0 degrees. And this is going to be over our I. Well, this is actually our V source over our I source, because it's finding the Thevenin equivalent, and that is what the Thevenin equivalent is, it's the source. So what we're going to do is put this over our I of S. Well, we found our I of S here, but we would have to convert this back to polar form. Fortunately, we've already found the polar form up here before we even converted it. So we are going to have 1.3 with an angle of negative 37 degrees. And in doing this, we are going to get approximately 11.4 0.5 with an angle of 38 degrees. Now we're going to need to convert this back to rectangular form, so we're going to use this equation. And if we do that, we get that our final ZT of h in rectangular form is approximately 9 plus our imaginary number of 7. And if we reveal the answer, we can see that we have approximately 9 and 7. So that is how you would go about solving for this problem.